At the end of the last video, we got that quadratic, and I was going through it trying to find the inverse Laplace. It's like, oh, this is not fun. And then I put an equation. I said, if you have let's take this one. I'll give an example, direct to an example. F of S equals 100 S plus 3 over S plus 6 times S squared plus 6S plus 25. I think that's the example we did at the end of that video. We can factor this. So instead of using quadratic and completing the square like we do normally in math, you can actually factor that to S plus 6. And if I remember, we did factor that. What was it? Was it S plus 3 minus 4j and S plus 3 plus 4j? That was on the end of the last video. If you use the quadratic formula to solve this, you end up with two solutions, and these becomes your factors. Again, remember your quadratic, in case you forgot. You go, I'm going to show you where these numbers came from. S will be minus b, which is 6, plus or minus the square root of what? 36 minus 4 times a times c, which is 100, divided by 2a, which is 2. Negative 6 plus or minus, this will be what? 64. The square of 64 is 8j. That's a negative number over 2. So s will be what? Negative 3 plus or minus 4j. So when you bring everything to one side, one factor will be s plus 3 minus 4j, and the other one will be what? S plus 3 plus 4j. So that's where these two came from, in case you weren't sure. Now, we can, since these are simple distinct roots, we can rewrite that as k1 over S plus 6 plus k2 over S plus 3 minus 4j plus, instead of k3, this one really will be k2 conjugate, because if you look at them, this one is the conjugate of this. Isn't 3 plus 4j is the conjugate of 3 minus 4j? So that would be k2 conjugate over S plus 3 plus 4j. And once I know what k1, k2, and k3, I'm in good shape. I can find the answer. And again, instead of completing the square, I'm trying to find a way to solve a problem like this. When you have this piece here, when you have something like k over S plus alpha minus j beta, I'm just writing in general there, plus k conjugate over S plus alpha plus j beta. And when you solve for k, you're going to find that k is going to be some value times has an angle to it, not times an angle. So it's going to be like 5 angle 30, 5 angle 40. You'll see that when we do that. But once you have a problem like this, we know what the solution to that problem is going to be. 2 times the absolute value of k, whatever the value of k we found out. Where's the equation for that? E to the minus theta t times cosine, that's what the solution is going to be all the time, beta t plus this e to the minus alpha t, I'm sorry, that's the theta here. That's alpha. Now, what is theta? Theta is the angle we're going to find, alpha. Theta is going to be, when we find the solution to k, is going to be 5 angle 30. That's what theta is going to be, that 30, you know? Or 2 angle 40. So that would be your theta is. The angle when we find what k and k conjugates are. So for example, I'll finish with you know what? I'll continue with this problem. You get to see it. But that's the method I'm going to be using to solve that. So let me find what K1, K2. Once I find them, I have the answer. So how do we find what K1 is? K1 is sitting on top of S plus 6. So I'm going to take my expression here, remove S plus 6 out of it, because you're multiplying by S plus 6, so that's why it disappears. I can either use the top or the bottom, it really doesn't matter, but the top would be easier in this case. And you want to find the value of that when S equals what? What value makes S plus 6 0? Negative 6. So let's plug it in. Negative 6 plus 3 is what? Negative 3 times 100? Negative 300 over. That's 36. Minus 36, 0 plus 25. That's a negative 12. Let's find out what K2 is. K2 is sitting on top of S plus 3 minus 4j. So take S plus 3 minus 4j out of that. So this piece is gone. So you end up with what? 100 S plus 3 over S plus 6 times S plus 3 plus 4j. And you want to find that when S equals what? What value makes this one 0? Negative 3 plus 4j? Plug it in. Negative 3 cancels the plus 3. That's plus 4j times 100. 400j over negative 3 plus 6. That becomes 3 plus 4j. And when S equals negative 3 plus 4j, that's 8j. Let's do the math here. The j cancels the j. That's 50 over. I got different calculator there. 50 divided by 3 plus 4i. Ooh. The wrong one. Where's the I on the TI 89?
I think it's you do a second.
Second.
It's like where catalog is.
Oh yes, thank you. Can I change that? I gotta go to mode now. I didn't use this in a while. What mode I need to be? Polar, right? It isn't polar.
Probably someone polar.
Which one?
You need a polar? Do you have in radians or degrees?
I have it in degrees. That's okay at degrees, but I think the other one.
No, that's right.
That's right?
Yeah.
What's the next button then I need to fix
You
on
hit the diamond and then hit enter again
that one? On the answer?
yeah, it should.
Diamond,
Green button.
Yeah,
Enter.
and then, there you go.
here we go. 10, I'm sorry. 10 angle negative 53. This is actually your theta, the 53, not the negative, because one will be negative, one will be positive. So your answer to this now, when you write that, what's the inverse Laplace of this? We know K1 is negative 12. That'll be negative 12. What's the inverse Laplace of 1 over s plus 6?
E to the negative.
E to the negative 6t. Now, the inverse Laplace of this whole thing is going to be 2 times k. K is that answer. This is your k. 2 times the absolute value of 10, e to the negative alpha. Alpha is 3. 3t. Cosine beta. Beta is what? 4t plus the 53 degrees.
Professor,
Yes.
in this case, wouldn't it be minus 53?
For
Or your angle.
the angle?
Yeah, the theta.
Yeah, because if it's, yeah, he's right, because if it's negative.
Plus
53,
the negative. Where are you looking? Oh, right there. Yeah.
This is negative.
Plus and negative 53 degrees. And that's your answer for the inverse Laplace. You can do it mathematically the way we did, and I'll do it the other way. The other way, you're going to have sine, cosine. They're going to use the Euler identity to put them together. So it's a lot of work, but that's sometimes easier because you're combining now the two answers. Because if you remember the way you did them in math, your solution, you broke it down to what? Yep. You broke it down to A or K, whatever you want to use, A over S plus 6, plus, you broke it down to BS plus C over what? S squared, because that's quadratic. Now, if I remember my math, we completed the square here. So we know what A. I already know A equals negative 12. I just did that. So that doesn't change. So it's negative 12 over S plus 6. And now I got to simplify this. I'm going to take the bottom and complete the square. That'll be S squared plus 6S. And now I'm going to take the 6 and divide it by 2. When you divide the 6 by 2, what do you have? 3, you square it, that's a 9. 9 plus 16, that's what 25 is. That's negative 12 over S plus 6. Now I'm going to write that S plus 3 squared plus what? 16 or 4 squared, you know? Now I need to know what BS and C equal to. And try simplify this. That's how we did it in math. I don't know if there's any other way you did it in math. I can't remember. But going back 32 years ago, that's how we used to do it in math. And I'm sure 32 years ago, math at that time and math today is probably the same. So to find what BC or BS plus C, if you do cross, you're going to find the LCD, which is this times that. So the 100 times S plus 3, I'll come back to this. I'm not done. I'm not even close to it. But we'll come back to it. I need to find what B and C are. 100 times S plus 3 is equal. That's just the top of this. Should equal the top of this. That'll be negative 12 times S squared plus 6S plus 25 plus S plus 6 times bs plus c. Is that how you did it? In math, in differential equation, linear algebra?
Yeah, sort of.
Differential, yep. That's the whole thing sitting on top. I just didn't put this. I was just trying to be lazy. On both sides. Nick, you said sort of. What other method did you guys use then?
Partial fractions of fractions.
Yeah, that's partial, but when you have a quadratic, did you, right?
I would try and break it up, like complete the square or something.
Yep. But that's where you have to know what b and c first before you can finish it, because then there's a shift there. So I need to know what b and c equal to. Now, I can drop the bottom because the same for both them. The coefficient of s squared equals the coefficient of s squared. Well, when you multiply this, if you look at the top of this, the s squared is negative 12 plus bs times s, that's b. The coefficient of s, what's negative 12 times 6? Is that negative 72? And here I have what? 6b and 1c. That's s. And the constant on this end, negative 12 times 25, is that negative 300? Plus what? 6c? All of that should equal to what? 100 times s, or 100s plus 300, if you multiply it through. And now you say, okay, the coefficient of s squared should equal the coefficient of s squared here. Well, there is no s squared. So 0 equals negative 12 plus b, which means what? b equals 12.
Yeah, that's totally right.
That's how you did it? Yep. The coefficient of s on this side should equal the coefficient of s here. So 100 equals negative 72 plus 6b plus c. You bring the 72 to this side, becomes 172 equals 6 times b. b is 12. Is that 72? c equals 100. And if you took the last equation, the constant here equals the constant there. 300 equals negative 300 plus 6c. You end up with what? 600 equals 6c. What's c equal to? 100. So you have to do this math to find what b and c are. So I was trying to avoid all this math, because we're not done. We're going to come back to this now. So here's what we have. We're doing partial fractions. So going back to this, right there, negative 12 over s plus 6. Now we said b is what? What was b? I forgot. b is 12 and c is 100. Then you got to do shifting. I got to factor 12 out. And if I factor 12 out, and I make the s plus 3, so that would be 36, right? That means I still have here, what, 64 now, instead of 100? Because it has to be 12 times 3, the constant, 36 plus 64, that's the 100.
You can just split them up. Right?
You could, but you're still missing a shifting here. See the s plus 3 in the bottom? So you got to make sure that's s plus 3 to find the inverse Laplace of it. Now you can split it. Now you can split it and you go, this is what? Negative 12 over s plus 6. Maybe I'll factor the 12 out of this one. S plus 3 over. I'm going to write this s plus 3 squared plus what? 4 squared. That's what 16 is. The next one, I want to make sure I have a 4 on the top. So if you want to have a 4 on the top, 4 times what is 64? Is it 16? And now you find the inverse Laplace of each one. What's the inverse Laplace of this one? That's negative 12 e to the minus 6t. Here's the 12. What's the inverse Laplace of that?
You have to take the shift out,
Get the shift, which is e to the negative 3t,
and then it's a
sine
sine.
4t.
Wait, why is it sine, not cosine?
Because there's an, the S on top.
Yeah, it would be sine. Yeah, it would be cosine.
Cosine, I think, yeah. If you have an s on the top, it's a cosine. If you have no s, it's a sine. Can you see it? So that, oh, I wrote a sine here, yeah. That's a I see what you're saying now. That's a cosine 4t, because you have the s there. And this will be 16 e to the minus 3t times what? The sine of 4t. So now you clean it a little bit there. Negative 12 e to the negative 6t. 12 and 16. Ah, that's a little bit different. 12 and 16. You see, the numbers are different. So I can factor out e to the negative 3t. And you have what? I can take a 4 out. 12 cosine 4t plus what? 16 sine of 4t. And then you're going to use some trig identities to actually combine these and see what you have to get your answer. Let's compare it to the other method. Let's see if we got some of the pieces in it. It says, here's my other method. Where was it? I said we're going to have negative 12 e to the minus 6t. We got that. We're going to have e to the negative 3t. We got that. Cosine, we try to use a sine cosine using shifting. Well, if you think about the sine and the cosine, what's the shift between sine and cosine?
So, pi.
Yep, 90 degrees. Pi over 2. You know? So, or you can use some of the trig identities when you have sine plus cosine. If you want to combine them together, good luck with the trig here. You know? This one combines them together and gets you that answer all. So my answer here is actually negative 12 e to the negative 6t plus 20 e to the negative 3t. I don't need to put absolute value of 10, which is 10. Cosine of 4t minus the 53 degrees. A little bit, I think, quicker than this method. A little bit quicker than this method. So you can use either one. If you try to match the answers in our book, they're probably not going to use this, because that means you got to have two sources now in our book. Where this one requires only one source here. Well, actually this source and that source, but I'm just looking at this one. This is one source with the shift versus two sources here. You have to have in your circuit. So that's how we handle usually quadratic. We go to this equation. We go 2 times the absolute value of k e to the minus alpha t cosine beta t plus theta. And once you know what alpha and beta, in this case alpha is 3, beta is 4, I need to know what k and theta is, and I have the solution. And you can find k and theta. Once you go through the math, that's your k and that's your theta. Let me try another example. don't think we have one single example in our book on a quadratic. They took the easy way out. Let me put another example. Maybe this time, you know what? I'll put repeated roots instead of quadratic. We didn't touch repeated roots. How do you handle them? We can do them the way we did them in math, or we can do them with our shortcut. Again, let's assume our function now, the one we just had, or we just modified just a little bit. What was it? 100 times s plus 30. Let's say it was divided by s times s plus 5 and times s plus 3 squared. I don't know why I use 5s. My 5s and s's look the same. So I can break it down to something over s, something over s plus 5, something over s plus 3, because you have repeated roots, and something over s plus 3 squared.
You care that it was s plus 3 on top, s plus 30.
Well, if it's s plus 3, cancel one of these. I don't want to cancel them, right? Because then you don't have repeated roots. K1, K2, K3, K4. I could have put any number there. I don't know. You chose 30 and 3 there. But if it was s plus 3 cancels one of these, you don't have repeated roots. So I do want to have repeated roots here. And again, to get K1 and K2 and K3, straightforward. I don't have to find the LCD and multiply them and add them. That's too much work. K1 is sitting on top of S. So you take S out of this picture. What's left? 100 S plus 30 over S plus 5 S plus 3 squared. And you want to find this when S equals what? What makes this one 0? 0. That's 3,000 over 5 times 9, which is what, 45? Clear. F1 to clear. 8. I forgot to do this. What is 3,000 divided by 45? Fraction. You know what? Let's do a little twist to it. Let's make it 180. Nothing wrong with the fraction. I just don't want to. Let's make it fraction here. Get rid of the fraction. Let's make it 180 instead of 100. So 180 times 30. 5,400. I hope that makes the fraction goes away. Divided by the 45. 120? Yep. Well, because this is 45, right? 80, 180. That goes into 4 times. That's why. So I just made that number a multiple of that number. I could have used 90 instead of 100, and that would fix it too. Thank you. So I just try to make this number a multiple of that number, so we'll cancel. But there's nothing. I get 200 over 3. It's not a big deal to leave it as 200 over 3, but I figured, let's get rid of the fraction. You get the idea with nicer numbers. Let's find what K2. K2 is sitting on top of S plus 5, so take S plus 5 out of that picture. That doesn't mean I'm not going to have fractions now, but I hope I don't have them. But now you want to find out when S equals what? K2 is sitting on top of S plus 5. So what do we do here? Is that negative 5? because it's sitting on top of s plus 5. So here we go. Negative 5 plus 30 is what, 25? 25 times the 180. It is 4,500. This is negative 5. Negative 5 plus 3 is what? Negative 2 squared 4. 4 times the negative 5. Is that a negative 20? Is it negative 225? K3. Notice now there's the repeated roots. Well, I'm going to find the value of this when s equals what? Negative 3. So if I only take one of these, what's going to happen? What are you dividing by?
S plus 5 times S plus 3.
Yeah, so it'll be a 0 when s equals negative 3. You can't divide by 0. So actually what happens when you have this is you take all of this out. Not just one of them, all of them. So you end up with 180 times s plus 30 over s times s plus 5. When s is negative 3, negative 3 plus 30 is 27.
So is it like K3 and K4 are equal?
Nope, you'll see that. 27 times the 180 will be what? 4860. Divided by, that's a 2 here, that's a negative 3. Is that a negative 6? Negative 3 times 2, that's negative 6. That's negative 810. Now becomes the difficult part. How do we find what K4 is? Again, K4 is sitting on top of S plus 3, so S is going to be negative 3. I can't just take this one out because that'll give me the same answer as K3, and they're not going to be the same answer. So to find that is you want the derivative. The derivative of 180 times S plus 30 over S times S plus 5. And if you remember your calculus 1, there's a fraction we have to use the quotient rule. So let me just clean it a little bit there on the next page. The derivative here. So the top is going to be 180s. I'll multiply through. Plus what's 180 times 30? 5,400 over S squared plus 5s. Remember, we used to call them u and v. U is 180s plus 5,400. V is the bottom, which is s squared plus 5s. You need the derivative of each one. What's the derivative of u? 180. What's the derivative of v? 2s plus what? 5? And the quotient rule says what? The derivative of that is v times u bar minus u times v bar, all of that divided by v squared. That's the quotient rule from Calc 1. S squared plus 5s multiplied by u bar, which is 180, minus u times v bar, 180s plus 5,400 times 2s plus 5, all divided by v squared so still some work involved in that. And God help us if this was cubed, by the way. If this was cubed, it will be another one, and that'll be the second derivative. Clean that a little bit. Combine the s squared, so what are you going to have? Negative 180 times 2 is negative 360 plus 180, negative 180 s squared. I'm trying to collect all like terms. Let's see what that number is. 180 times 5 plus 5400 times 2 multiplied by negative 1 plus 180 times 5 I got negative, I think 10,800. Is that what you got? If you collect all like terms. S. Now what is my constant? It's a negative 5,400 times the 5. I'm just collecting all like terms. 27,000. So you want to find now what K4 is? It's the value of the derivative when s equals negative 3. So what is K4? So it's going to be, when s equals negative 3, that's a 9. 9 times the negative 180. Negative 1620 plus 10,800 times negative 3 or 3. That'll be a plus 32,400 minus 27,000 all divided by negative 3 squared is 9. 5 times the negative 3, negative 15. What's 9 minus 15? Negative 6. Square that, 36. $105 if I push all the right button. You know what? Where was it? Where was the problem? Oh, the pages. Actually, the fourth one, that should have been K4 and that should have been K3 backward. This is sitting on top of all of them. That should have been K4 here, not 3. I just thought of it. That's the 4, and the one with the derivative is this one. That's the 3, not the 4. My memory is failing. So that's K3 actually, not 4. The 1, so the 1 actually that's sitting on top of this, when you find it, straightforward, that's a square. You get rid of all of that. But you can't just get rid of one of these. That's where you take the derivative. K3 is actually the derivative. And if that was, again, if this was 3 here, That would have been K4. K3 will be the first derivative, and K2 will be the second derivative of that answer, which means the derivative of this. So now we get all the pieces. So here's my answer. F of S equal to, what was K1? 120 over S. K2, what was K2? That's a negative 225 over S plus 5. What was K3? I just found K3. That's the derivative one. 105 over S plus 3. What was K4? K4, oh, we know what K4 is. We found it. What is K4? Negative 810 over S plus 3 squared. Now, can we find the inverse Laplace? Make sure try and keep them all done. So again, what's the inverse Laplace? Who has a derivative 1 over S? Isn't that the unit impulse function? Not impulse function. Isn't that delta, whatever we call it? 1 over S u sub t, unit step function. So this will be 120 u sub t. I don't know why I put a plus, it should be a minus here. Negative 225 e to the negative 5t plus 105 e to what? Negative 3t. Now this is a little bit different. Negative 810. Isn't that t e to the negative 3t? Let's see if we have that. The inverse Laplace of 1 over s plus alpha squared. It's t e to the minus alpha t u sub t. Notice actually all of these have u sub t in them. In math, they don't have u sub t. Again, in circuits, we have u sub t because when you go to the lab and build that, that's time equals 0. So we always add u sub t to each one. So your final answer for this, when you clean it, it is 120. I'm not going to put u sub t, minus 225 e to the minus 5t plus 105 e to the minus 3t minus 810 t e to the minus 3t, the whole thing u sub t. Look and see if I can find another example here.
Can you put up the previous page real quick?
Previous page.
Yeah. Oh no, wait. The one with K4 on it.
K4 was just direct substitution.
Okay.
Here is actually a shortcut to remember when you're doing the inverse. Just remember these rules. remember these rules. If you have k over s plus alpha, the inverse Laplace of that is what? K e to the minus alpha t. If you have k over s plus alpha squared, these are the common one that we use. The inverse Laplace of that is what? K t e to the minus alpha t. If you have k over s plus alpha minus beta, or j beta here, and the other one k conjugate s plus alpha plus j beta, your answer is going to be 2 times the absolute value of k e to the minus alpha t cosine beta t plus theta. And if you have, sometimes the bottom ones are squared, s plus alpha minus j beta squared. Notice there's like a factor here, like it looks like this one. You're going to multiply it by t. For that is going to be, just multiply this answer by t, just like this one. So it's going to be 2t, the absolute value of k, e to the minus alpha t cosine bt plus theta. With all of these, we always add in circuit u sub t. Always. In circuit, you're going to see the u sub t added to the answer. And if you remember these, you really can solve almost any problem. Let's take a quick one just on these. I'll throw a couple of rules quickly. I'll make them simple enough. I'll repeat basically some of the examples. You're done? Still writing? Okay.
What is the same?
Just there's a t. That's a square. You add a t to it. Yep. Notice with this, the square here really, see the square? Added the t. The square here in this one, it takes the top answer and adds a t to it. That's what it does when you have this square. I'll do a quick couple of them, and then I'm done with the inverse, and next class we'll start doing some real application. Let's say I just have this problem. I'll make it simple enough. 30s plus 100 over s squared plus 9s plus 20. Once I have the s squared, my mind immediately is going to go in this direction, into this one. I just got to find what alpha and beta is. So I'll take s squared plus 9s plus 20, and let's factor that. That's negative 9 plus or minus the square root of 81 minus 4 times a times c. 4 times 20, which is what? Oh, wait a minute. 4, that's 80, divided by what? Well, I can factor that. What am I thinking, huh? Because you can factor that to what? Yeah, plus 4 plus 5. I didn't mean it that way. I'll do a different one. Okay, I'll leave it. I fell asleep there. I was about to look at that number. That's a 1. You know, that's going to give me negative 9 plus or minus 1 divided by 2. It's not going to be any j in it. So I knew that wasn't right when I put there. So I'll change that number in a minute. Instead of 20, I'll put a 10 here. We'll go through it. So, but I'll leave this one, so I don't want to throw it away. So if you factor the bottom of this is really s plus 4, s plus 5. So to find k1, k1 is sitting on top of s plus 4, so s plus 4 is gone. 30s plus 100 over s plus 5 when s equals negative 4. The bottom is 1. So what do we have? 30 times a negative 4 plus 100. Is that negative 20? And what's K2? K2 is sitting on top of s plus 5, so 30s plus 100 over s plus 4 when s equals what? Negative 5? Negative 5 plus 4 is negative 1. Negative 150 plus 100, negative 50. So I can write that as K1, which is negative 20 over s plus 4, plus K2, which is 50 over s plus 5. And I just said, if you remember K over s plus alpha, is this the answer? So what is your function as the answer as a function of time? This is f as a function of s. Negative 20 e to the negative 4t plus 50 e to what? Negative 5t, add u sub t. That's it. Those are really straightforward. The quadratic and the repeated, they become a little bit tricky. So let's put one where this is actually not doable. So what should we put for numbers so we have nicer numbers? 81. If I make that 18, what's 4 times 18? 72. Perfect. Let's make that 18 instead of 20. Same problem, but make it 18 here. Everything else is the same. So 30s plus 100 over s squared plus 9s plus the 18. Anytime I see quadratic, if I can't factor it, I go, let's solve it. Negative 9 plus or minus the square root of 81 minus 4 times 1 times 18, which is 72, divided by what? 2. Negative 9 plus or minus the square root of 9j, square root of 9, which is what? 3j, divided by 2. Negative 4.5 plus or minus what? 1.5j. So when you bring these to this side, this becomes a plus, and one of these plus, one of these minus. So this would be k over s plus 4.5 minus 1.5j. And the other one is going to be k conjugate over s plus 4.5 plus 1.5j. Remember, if you factor the bottom here, if you factor s squared plus 9s plus 18, you end up with this. S plus 4.5 minus 1.5j. And s plus 4.5 plus 1.5j. Well, you want to do the k over the minus. Yep. So to find k, is going to be 30s plus 100 over s plus 4.5 plus the 1.5j. And you want that when s equals what? What makes this one 0? Negative 4.5 plus the 1.5j. So let's do the math. So let's see what we have. 30 times negative 4.5. Negative 135s. Oh, I mean, not s. Negative 135. There's no s here. I'm replacing s with that number. Then I got to add 100 to it. I'll leave it like this. I'll do it in 2 steps. What's 30 times 1.5? Is that 45? When s equals negative 4.5, that cancels the plus 4.5, 1.5 and 1.53j. So that's equal to what? Negative 35 plus 4.5j over 3j. Let's see what that number is. 35 here.
45 here.
Is it 45? Yes, not 4.5, 45. Thank you. $45, not 4.5. 30 times 4.5 is 45. So negative 35 plus 45i divided by 3i. And I came up with 19.00 angle what? Roughly 38 degrees. This is your theta. This is your k from the equation. Here's my solution. This is my alpha, the number itself. The 4.5 is alpha, not the minus. Excuse me. And this is beta. Once I identify these, 2 times the solution, f of t, 2 times the absolute value of k, e to the minus alpha t cosine beta t plus theta. My solution to this is going to be 2 times the 19. I don't need an absolute value for the 19. E to the minus. Alpha is just, now without the sign, is the 4.5. Cosine. Beta. Beta is the 1.5. And theta is what? 38 degrees. 2 times 19, which is what? 38? E to the negative 4.5t cosine 1.5t plus the 38 degrees. Not that bad. Do them this way. Not bad at all. Much easier than normally we do them in math. I'll do a repeater roots, but I'll try to make it easy because we're short on time. Then next time we just go into the application. I just want to make sure you can do the inverse. The Laplace is easy, but the inverse is always the tougher one. So here's my f of s. I'll make an easy one. Anyone pick a number between 0 and 10, not a 5. 9. I just don't like the 5 because it looks like an s for me. S plus 4 cubed. Try to make it easy. I can write that as what? K1 over S plus 4. K2 over what? S plus 4 squared. And K3 over what? S plus 4 cubed. I'll start with K3, the 1 over S plus 4 cubed. Because you multiply this expression by that, so if you do that, you're going to lose S plus 4 cubed. When S equals what? Negative 4? Well, it just happens to be what? 9. You want to find that when S equals negative 4, so what do you have? Still 9. Doesn't matter what S is. The S plus 4 will cancel the S plus 4. It's gone. K2 now is, notice this is short 1. It's the derivative. The derivative it's going to be zeros here. Let's change it a little bit there. We'll go 9, change a little bit the problem. See, when you wing it, how about 9s plus 2? I'm changing the question. Because I try to wing it quickly, and I realize now, looking back, like, because F2 is the derivative of the remainder. And what's the derivative of that? 0. Derivative of 9 is 0. What's the second one? The second derivative, 0. Defeats the whole purpose. Maybe I should make it even S squared.
So what would you do in that case? Are you just saying like?
Well, it'll be 0, 0. This will be 0, and that will be 0. The only thing you end up with that one. Yeah. So now that'll be the derivative of the remainder. Well, the derivative of the remainder happens to be what? 9. Remember what we did here.
K3 changes, by the way.
Which one? Oh, yeah, K3 will change.
I changed it, it's just
1.6 now? So this will be 9s squared plus 2 when s equals negative 4. Negative 4 squared is what? 16. 16 times 16 times 9. Calculator goes to sleep on me all the time. Plus 2, 146. Thank you. Now K2, we take the derivative. We eliminate s plus 4. We take the derivative of the remainder of that. When s equals what? Negative 4. Now what's the derivative of this? Isn't that 18s? When s equals negative 4. 18 times a negative 4, negative 72. And what is K1? K1 is the second derivative of the 9s squared plus 2, which is the derivative of 18s. What's the derivative of 18s? 18 when s equals negative 4. And what's your answer? 18. I try to make it really simple because I'm looking at the clock, so I gotta go. So that's why the derivatives quickly here. So what's that? K1, which is what? 18 over s plus 4. K2, which is what? Negative 72 s plus 4 squared. K3, which is what? 146 over s plus 4 cubed. We know the answer to this and this. That's one of the shortcut I gave you. This is what? 18 e to the negative 4t minus 72 t e to the negative 4t. And what happens when you have t cubed? This is what you told me last time. You said the derivative when you have t to the n becomes what? S to the n plus 1. So this is a cube. That means actually t squared here, right? When you have n, this is n plus 1. So when you have n plus 1, this one, the original function, has 1 less. So if this is cubed, that means that was a t squared. And the only problem is that number. What is that number?
N factorial.
How about n minus 1 factorial? 2 factorial. What's 2 factorial? Isn't that 2? That's 146 divided by 2. The 2 factorial, which is a 2. So that's 73. And add u sub t. And that's a recap of all the techniques.